We're going to take a look at the intermediate value theorem. So it's written up here, but I'm going to illustrate this with a drawing. So let's put some curve here. We're going to call this f of x. And then I'm going to take a look at an x value at A, and I'm going to also look at an x value of B. Now, what the intermediate value theorem says is that if you look at the y value at A and the y value at B, if they both have opposite signs, so one negative, one positive, or positive, negative, doesn't matter, that means that the graph must cross the x-axis. So for instance, this drawing here, we see that it does cross somewhere between A and B, and this would have a negative y value at A, and at B, it would have a positive y value. So this is saying that if that happens, if they have opposite signs, then we know that the graph crosses at least once. Now, it might go up, go down, and it might do a couple other things in there. So we know it has at least one zero on this interval from A to B. That's what the intermediate value theorem says. So for these problems like this, just wants to determine whether the intermediate value theorem guarantees that this has a zero on the interval 0 to 1. So all you have to do here is you just have to find out what f of 0 is and f of 1 is, and then that's going to tell you or not whether it has a 0 if the y values are different. Let's do that. Let's first start with f of 0. So that means that we just put 0 in for all the x's like that. And we get negative 1 is the answer. So that's the value of f of 0. Well, let's also try f of 1. Okay, so we have 1 cubed, 13 times 1 squared minus 1. So this is going to give us 12 plus 13 and then minus 1. Okay, well, this is 25 minus 1. That equals 24. So notice that we've got f of 0 is negative 1, and this is positive 24. They have opposite signs. So since f of 0 and f of 1 have opposite signs, there is at least 1 0 on the closed interval 0 to 1. So that's basically what the result of that means. Okay. So that's basically what you would say for something like this. Since f of 0 and f of 0 and f of 1 have opposite signs, there's at least 1 0 on this. So we know for sure that the graph will definitely cross somewhere between 0 and 1 at least once. It might cross more than that, but we know there's at least 1 0 that's here. We're going to do another one of those. So let's look at a fourth power this time. Okay, so determine whether the value theorem guarantees that this has a 0 on the closed interval from 1 to 2. All right, so first we're going to try f of 1. Okay, so we'll put that in here. Okay, so just putting a 1 in for all the x's. Then we want to simplify this. So 1 to the fourth is just 1, so 8, and this is going to be minus 3 plus 4 minus 1. All right, so here, 8 minus 3 is 5. 5 plus 4 is 9. 9 minus 1 is 8. So I know that f of 1 equals 8. Now let's try f of 2. Okay, so we'll put that in here, squared. 4 times 2, so 2 in there for all of the x's. So now we're going to simplify each of those. This is going to be 8 times, this is 16 here, minus 3 times 4. This is 8 we can do right away, and then minus 1. Okay, so now we're going to keep continuing with that. And so the first part's going to be 128 minus 12 plus 8 minus 1. All right, so if I take all this and combine it together and do all that at once, then we're going to get 123 for the answer on that. Now, both of these are positive, so they don't have opposite signs. Now, when that occurs, we can't make any assumptions about whether there is a 0 on this closed interval. So basically, we say no conclusion can be made on this problem. Okay, so whenever that happens where it's not opposite signs, we basically say no conclusion can be made about whether there's a 0 on that interval or not. Okay, so you can only have that occurring if you have opposite signs. If you don't have opposite signs, then we basically all we can say is no conclusion can be made. It may or may not have a 0 on 1 to 2. We can't make a conclusion about whether there's a 0 on that because we got 2 positive values here. So if it's positive and positive, that means the graph does not cross the x-axis at that point. And so again, we just say no conclusion can be made.